Hello everyone, this is me. I'm updating another video this time, and it's going to be the external interrupt video. I'm having an absolutely great time now, so expecting a lot of videos coming in the next few days. Alright, so external interrupt is when you trigger an event from external bin. And it usually works in two modes, rising edge and falling edge. So if you have your external bin, like a push button or whatever signal you have, and when I trigger an event, so you can configure it to trigger a rising edge or falling edge or both of them at the same time. So in my demo today, I'm going to use my external push button to interrupt my main routine. And what it's going to do is that when you click the button, it will do something and then get back to the main code. And for the STM board has got only 16 external interrupt lines. Well, I'm saying only, but I think it's quite a lot for an embedded device anyway. And each external interrupt X corresponds to pin X. And what I mean by this is that external interrupt line 0 can only be connected to one of the pin zeros on any port. And you can only connect one at a time. So if you're connecting PC0 to external interrupt 0, you cannot use any of the 0 pins simultaneously. If you need any other external interrupt, just connect it to a different pin number. Okay, I'm not going to talk too much about external interrupts because you might already have some ideas about external interrupt before you decide to click on this video. But for those people who don't know much about external interrupt, let me give you a 30 seconds motivation on why we need it. External interrupts usually used with sensors. So if we have sensors that read and acquire data on a regular basis, what we do, instead of reading the device continuously, people usually use its interrupt line. So for this MPU 6050, it has got an interrupt line that we can program it to send a rising edge or a falling edge whenever a data is ready. And that's where external interrupt is useful. Another example is this ENC28 device that I've used it myself. This Ethernet controller, when you receive a packet, you can program it to send a trigger through the interrupt line. So the microcontroller wouldn't have to, again, continuously read this device and check if a message is available. We just rely on the interrupt pin. When it sends a trigger, then we know that we'll receive a packet. We can go read the device and get the data. Okay, so I hope you found this very motivating. Okay, so in my demo today, I'm going to use my external push button to detect a rising edge to emulate the external interrupt of a sensor. And I'm going to show you how to do this with and without CubeMX. So let's make a start. Okay, the first thing we need to do here is click on New Project and select the right board, STM32F4 in this case, and it's VGT. And for the pinout, we need to enable PA0 and set it to external interrupt. External interrupt 0, of course. This one. I'm also going to enable a few LEDs because I'm going to use them in my demo today. Now we need to go to the configuration window and enable the external interrupt line. So click on NVIC, Nested Vector Interrupt Controller, and we need to take the external interrupt line 0. And that's it, that's everything we need to do here. Click OK and generate the code. Give the project a name, I'm going to call it XTI1. Select the right IDE, mine is MDK ARM v5, and click OK. Click on Open Project, and this will take you to Keil Macrovision. On Keil Macrovision, we need to expand this folder and open the main. And CubeMX generated the low-level functions and configurations for us. And what I need to do here is I need to define the external interrupt callback first. And I can find a template in the GPIO file. So when you go to Functions, GPIO, expand this, and you will find external interrupt callback, this one. And I need to redefine it in my main, but without the weak object. I'll define it at the bottom here. And in here you can add your code, whatever you want to do when the push button is pressed. And I want to toggle one of my pins. I'm going to toggle the green pin, for instance. Sorry, I mean the green LED. And let's GPIO pin 12. I'm also going to add some delay to reduce the effect of switch bounce, because every mechanical switch has got something called switch bounce, which is a multiple ons at the same time. So this is a basic delay of a few milliseconds perhaps, or microseconds, using for loops. And in my main, I'm also going to toggle another LED at a certain rate so that you will see that my main is implemented and the external interrupt will just change the LED status, but everything else will be running the same thing. And I'm going to add a delay of half a second, for instance, and that is everything. And just a quick remark before I carry on, you see this small delay for mechanical switch debounce. You wouldn't need this if using an external sensor, because usually external sensors has got some output filter that filters all the ripples out. This one is only for mechanical switches, and ideally you don't put any delays, you just put a filter on the pin, just a low pass filter, but this is just for demo purposes, but you would never want to put any delay in external interrupt callback. Alright, okay, so let me compile the code and load it to the board. Okay, compiled without errors, let's load it to the board. Perfect. Now let's have a look at the board and look at the LEDs. Okay, this is working. That's how to implement external interrupt using CubeMX. And if that's all you're looking for, you may pause the video here, and if you found it helpful and you want to see more videos like this, don't forget to like and subscribe. But now I'm going to carry on and I'll show you how to do this without CubeMX. And to implement external interrupt without CubeMX, we've got to start everything from Keil Microvision. So I need to go to project and select a new Microvision project. You need to select a folder to store your files in and give the project a name and click save. And we need to select the board, STM32F4 and its VGT. And now we need to select the software components. As usual, you need to enable the core software component. We need to go to device and enable the startup, a cube framework, and we need to enable classic. And classic depends on other software, so we need to click resolve so that they will be added automatically. And now I need to expand hull driver and enable GPIO, but it's already enabled. So that's all. Click OK. Right, you see Keil Microvision generated these project files for us, added the required hull drivers, but it didn't add a main, so we need to add it manually. So click on new, it's a C file, I need to call it main. On my main, the first thing I need to do is to include the STM header file, the STM hull library header file. Then I need to create the main function, so int main void and the infinite while loop. And I need to configure my GPIO pin, so I need to enable PA0 and set it to external interrupt to interrupt on the rising edge. And I need to enable my LEDs. And I'm going to do this in a separate function. I'm going to call it GPIO config. Okay, let's define the function down here. And the first thing we need to do here is we need to define a GPIO init type diff to initialize the pin. And I'm going to call it my pin init. And I need to enable port A clock and port D clock using these two functions. And now I'm going to set up my PA0 pin first. So the pin is going to be pin 0, and the mode would be interrupt rising. And now I need to call hull GPIO init function to implement those initialization. This is going on port A, and I need to pass the init type diff as a pointer. And this will implement the configuration for PA0. And for my LEDs, I can still use the same type diff. And I'm using two LEDs, PD12 and PD13. And the mode to output push-pull. And now I can call GPIO init function again, but this is going on port D and passing the init type diff again. And now one last thing in here is I need to enable the external interrupt line by using these two functions. And now I need to define my external interrupt callback function. Just like what I did in CubeMX, I'm just going to copy it over to here, just like in here. Well, and in fact there is one more thing we need to do here. We need to match the XTIRRQ standard device callback to the hull library interrupt function. So we need to define something like this. This is usually defined in hull library.it file that is defined, that usually added by CubeMX, but because we didn't use CubeMX, we have to define this manually in our main. And all this line of code is doing is that the STM is programmed to jump into this XTI IRQ handler, not the HAL library one. Because what if you don't want to use HAL library? Would the external interrupt not work? No, it's gonna work, but it's programmed to jump into this handler. And this is defined at the start of file, in fact. So you see, it's programmed to go to XTI IRQ handler. So I hope this makes sense. So this is all for the configuration, but there is one final thing we need to do, and that is to include the systick interrupt. Because we want to use HAL delay in our main, I need to enable systick interrupt and define its IRQ handler as well. So this is to enable the systick interrupt. You write these three functions, and I need to do something like this for its handler. Okay. So this will increment the millisecond tick and will go to the IRQ HAL handler. Right, so now we're ready to write our main function. First step is to call HAL init function that I usually call, and then the configuration function. And in our infinite while loop, just similar to CubeMX, we need to toggle a pin every half a second. So that's all. Let me compile the code and load it to the board and see if it's going to work the same. Most probably it's not going to load because I need to use the right debugger. Exactly. So go to options for target, go to debug, and select ST-Link debugger. And also go to settings and enable trace. Core clock to 16 megahertz, and click OK. Now it should load fine. Perfect. So let's have a look at the board. Alright, perfect. This is working as well, and that's how to implement external interrupt without CubeMX. And this brings me to the end of my tutorial today. Thank you very much for watching, and if you found this helpful and want to see more videos from me in future, don't forget to like and subscribe. See you next time.